So good afternoon. I'm Tao, and as you can see from slide, my major is agricultural biological engineering. So it's not in domain of GIS, but it's fortunate for me to have a chance to work with Xiaowen to work on this topic. So the topic is about the CyberGIS decision support platform for a sustainable bio-based system. So why we need that? So as we can see, biofuel or bio-based systems are real. So in 2012, the ethanol production is about 8% of total transportation fuel consumption. So it's a big industry right now. And from this figure, we can see in the next 10 years, the whole new renewable fuel will increase significantly, at least double the capacity. So for that new facility or new industry, what can we do to facilitate design and operate this new industry is a complex problem. So we need some tools to facilitate this decision making. So for a typical biofuel production pathway, so it has several steps. So from biomass production on field, then move biomass with transportation, and then do some pre-processing to do the size reduction and densification to help to the transportation. And we need to store the biomass for the all year long processing. And then the biomass need to move to the biorefinery to do the final conversion. So this is a complex system, and in each step, they have multiple options. So how we can optimize or evaluate this system has a really challenging. I'm fortunate to be a part of this research group called Engineering Solutions for Biomass Feedstock Production. This group has been working on the sustainable biofuel production for more than 5 years. And in this group, we have 5 tests. So from the pre-harvest crop monitoring, which use remote sensing and machine vision technology to monitor the crop growth. And we have harvesting group try to develop new techniques to improve the harvesting efficiency or effectiveness. We have a transportation group help to monitor the movement of biomass and how to do better size reduction technologies. And for storage, we monitor the property change of biomass throughout the year. And in the middle is called the System Informatics and Analysis group. So I'm a part of that group. So this group try to integrate these other 4 tests together to make this system better. So how we can make this, we consider in our test, we have 3 major tests. So one is informatics, how we can find better ways to collect, manage data, feed into database and share the data. In the middle is called modeling analysis. We develop computational tools to evaluate, simulate, optimize all the systems. And then we want to move the information and modeling analysis tools to the decision system, web-based decision system, to facilitate this decision. And we consider biomass supply chain optimization is a good tool to facilitate this model analysis. And within that, there are 3 levels of supply chain decisions. So for long-term decisions called strategic level, the decision usually lasts for several years. So which relate to where to build a facility, how big the facility is. And in the middle is called tactical level. So it's a monthly decision. See when or how we use a purchase equipment, and what our harvesting and delivery schedules during different seasons. And downside is operational level. So it's day-to-day monitoring about the fleet dispatch and vehicle routing problems. So this topic, this presentation, I will focus on the strategic and the tactical level decisions. So why we need this? Because spatially, biomass feedstock production varies geographically. I provide these 2 Illinois maps. So one is the energy crop availability map, because the crop land area difference and the yield difference among different counties. So the county availability is different. And on the right side is the biomass production cost. And because the land opportunity cost, because the yield difference. So the unit production of biomass in each county also varies. So because this complexity, even just for Illinois, so we need some tools to say, if we want to build a new facility, biorefinery facility, where to build, and where to source the biomass, and use what formats. So then, for that regarding, we develop a model called bioscope model for the strategic planning. So we consider supply chain has 3 stages, from farm level, and then move biomass to the centralized storage and pre-processing centers to do some size reduction densification to move the biomass more easily in a uniform format. And then this uniform biomass can be further transported to the refinery to do the ethanol conversion. And the strategic decision will be the facility location, capacity, and resource allocations. Because for any decision-making tool, we need a lot of scenario analysis. This 8 figure shows if we achieve the same demand using different crop plant usage land, what's the difference for the supply chain configurations? And we can see if we use 20% of crop land to grow energy crop, then we only need 3 counties in the right down. And but if we use 2%, it requires more than 30 counties. So it's a huge difference. And so this figure we are developing is called integrated biomass supply chain model. We put the strategic and tactical together. So the green decisions are strategic level, and the red ones are the tacticals. So we optimize all these decisions together. So I talk about the models. So we face several challenges, and we hope CyberGIS can help our to solve these challenges. So in the regular way, we usually say collect data into like CSV files, feed it into optimization model. Then run the model, get the results in numerical results way. And we match with the reference, spatial reference data to put in a map, and then put in a map-based visualization. So we have 3 major challenges. First, most of these models are PC-based. And so we have a limited user access. And because the optimization problem usually is NP hard problem, it takes some time. So whether we can find a way to use high performance or high throughput computing infrastructure to facilitate this problem solving. And last one is like, as we can see in the workflow, it's not integrated. We may use different like softwares, and probably we need some domain expert or some like computer scientists help with this. So we need some integrated workflow. So our vision is try to develop a decision support platform, incorporate the database or GIS, help to manage the data. And we use the process modeling or technology economic model to evaluate different technologies. We use operations research method to develop optimization model to optimize system. And we leverage cyber infrastructure for the complex problem solving. And last, we want to visualize the results in a map or on a web. And I can see for CyberGIS probably can help with GIS results visualization and cyber infrastructure. Link these together to make it happen. So, and as I mentioned, the Bioscope model has been integrated to the CyberGIS platform, and we look forward to your feedback if you have a chance to play with it, and we look forward to your feedback about this. And this is the last slide. I only have 2 minutes. Yes. So for the future work, so how about sustainability? So how we can build a sustainable bio-based system. So what we have done before is more about engineering perspective, how we evaluate test the technology. And we need the social economic perspective, say what will be the social welfare impact, what's the energy, or what's the impact to the existing industry. And the other major part environmental, because it's a new industry, it may affect the water energy usage, greenhouse gas emissions, and the land use change. So we want to develop this platform to incorporate this perspective to make a better decision. So I think with that, I'd like to have 1 more minute for the questions.
Thank you.
Yeah, thank you.
Any questions for Tao? Thank you very much.
Thank you.